Assalamu alaikum, guys. Today we are going to speak about another new topic, that is the trigonal planar bipyramidal electron pair geometry. This is Najmunisha Ashab. I'm going to explain you how this trigonal planar bipyramidal electron pair geometry going to change, going to make an impact on the structure and bonding. Let's we move on to the chapter. First, we have to go to the content. So here we are talking about what the trigonal plan. Sorry. Here we are going to speak about what? Trigonal bipyramidal electron pair geometry. So, belongs to this geometry, we have several shapes. That shape we are going to study one by one. Therefore, the content is an introduction about your geometry. Next, the trigonal bipyramidal shape. What is that mean? And from that, we have derived the seesaw shape, T shape, finally linear shape. There are four possibilities under trigonal bipyramidal electron pair geometry. Let's we move on to the interaction now. Yes, trigonal bipyramidal electron pair geometry. Here, there are 5 Vesper units, right? Repulsive units around the central atom. So how actually we already studied how this geometry has thrived. When you have the 5 Vesper units or repulsive units around the central atom, then only we are telling that particular central atom having the geometry as trigonal bipyramidal electron pair geometry. These are arranged in 4 different types when bonding and lone pairs are considered. Actually, again and again, I don't want to insist about this thing, right? When you speak about the Vesper units, definitely we are calculating what your bonding pair and the lone pair, right? Bonding pair means what? Though it is a single bond, double bond, triple bond, we are considering that is as a one Vesper unit, as well as when you take the one lone pair, that is another Vesper unit, right? According to that, if you have the 5 Vesper unit, that the geometry is trigonal bipyramidal electron pair geometry. Under electron pair geometry, you can see 4 different types, right? When bonding and lone pairs are considered. So the first one is trigonal bipyramidal shape. We have 4. I just step into the first one, that is the trigonal bipyramidal shape. Here, all 5 repulsive units around the central atoms are bonding electron pairs. So what they are telling us, what is the actual shape of the trigonal bipyramidal? Okay. Sorry. So before step into this, okay, I just want to say, what are the shape present? Because already I have said in your content, but even though I just will say one by one, then you will be understand. When you take the trigonal pair, trigonal bipyramidal electron pair geometry. So just for the overview, I will say now, then we will look one by one. So you will understand what I'm going to speak. So when you speak about this geometry, let's we draw and see, right? So what is the definite structure? If you take your central atom as X, you will have the trigonal planar. One axis is a trigonal planar and another axis perpendicular. So all are at the plane. So this is what we are telling is trigonal planar. So you should have here 5 Vesper unit. Sorry, Vesper unit. So long there below this, we told we have 4 possibilities. So if you have 5 Vesper unit, right? All 5, okay, all 5 bonding pair. What is the shape? Yes. The shape is trigonal bipyramidal shape. So next one. Okay. I'll use another color. So here you are having 4 bonding pair plus 1 lone pair. This shape we are calling seesaw shape. There are other names, distorted seesaw shape and the regular tetrahedral shape. We will talk about that detailedly under the chapter. Next possibility. If you have 3 bonding, pair plus 2 lone pair, the shape is T shape. The final one is when you have 2 bonding pair with 3 lone pair. The shape is linear. So this is what I'm just going to speak with you all guys. Okay, there are 5 types of, there are 4 types of the shape under the electron trigonal bipyramidal electron pair geometry. So this is the first one. If you have the 5 bonding pair, why? When you speak about this geometry, you should have the 5 Vesper unit. If all 5 Vesper units are bonding pair, we are telling that is as a trigonal plane bipyramidal shape. So the second shape is when you have the 4 bonding pair along with 1 lone pair, that definitely the name is the seesaw shape. If you have the third one, 3 bonding pair with 2 lone pair, the shape is T shape. Finally, the fourth one, you are having the 2 bonding pair with 3 lone pair, that the shape is the linear shape. So we will speak this one by one. Then you will understand what we are going to study here, right? So let's move on to the trigonal bipyramidal electron pair. Let's move on to the trigonal bipyramidal shape, right? So this is what the trigonal bipyramidal shape. I already said. So what is mean by the trigonal bipyramidal? If all 5 repulsive units around the central atom are bonding electron pairs, the name is trigonal bipyramidal. Should be very careful about it. Okay. So this is the best example for PCl5. I already told you this is what, when you speak about the trigonal bipyramidal geometry, we said the trigonal planar, that is another axis perpendicular to your planar, but all planar at the, all the trigonal and the linear should be what in one plane. This is what we already spoke every time, right? So this is, you can see definitely this is the shape of what? PCl5. So can you count? 1, 2, 3, 4, 5. 5 Vesper unit, and the 5 Vesper units are all bonding electron pairs. Therefore, what is the shape of the PCl5 is trigonal bipyramidal. right? Let's move on to the next one. This is the seashore shape. So when you listen this word, you can understand what they are telling is, right? I already said what is meant by the seesaw shape. You are having the four repulsive units bonding while the remaining electron pair is a lone pair of electrons. So simply you can say this is what? Four bonding electron pair plus one lone pair, which is equals to C. So shape. That's all, right? Okay. So what they are telling is, let's move on to the example. We have taken the SCl4. So here you have two possibilities. Okay. I'll just draw and see. After that, you can see the example. It will be little more clear, right? So when you take the sulfur, right? So you might have the two. So according to that, 1, 2, okay, 3, 4. 1 is lone pair. And these all are, right? Seesaw shape. This is one possibility, right? So there is another possibility. That's why I want to show you. 1, 7. Okay. This is another possibility. So when you have the four repulsive units along with one lone pair, there are two types of the possibility. So here we are speaking what? A, B, right? Always the A is stable than B. Why? The repulsion at this stage is less compared to here. Why? We have studied about the bonding pair, lone pair repulsion. So according to this, you can see this axis as a symmetrical way. So the repulsion is less. Therefore, the structure A is stable shape of the seashore, right? Let's speak. There are two possible positions for the lone pair at the S atoms of the SCl4 molecules as shown below. So this is what I said A. You should be able to draw. If you fix the shape of the trigonal bipyramidal, then you can draw whatever. There should be 5. But is that one is the trigonal plane, another is a perpendicular, another axis is a perpendicular for that. This is what you have to understand. So along with that, when you speak about the 4, you should be able to draw. There is the 2 type of the shape. So that is seriously, it will say about what? Seashore shape, right? This is what they said. The structure A has a less repulsion than the structure B. Therefore, the structure A is more stable than structure B as per the Vesper model. Okay. The theoretical shape of the molecules with 4 bonding pairs and 1 lone pair of electrons is called seesaw, distorted seesaw, irregular seesaw shape. This is what it's not actually seesaw shape. That's why they are giving such kind of the name distorted seesaw or irregular seesaw shape. If you give the seesaw shape, that is also enough for your examination, right? So why we are telling like that is the imaginary axis for lone pair of electrons and the 2 SCl bonds are in one plane, while the remaining 2 SCl bonds are placed perpendicular to this. Why we are telling that? So we already know. So what they are telling is, I'll just draw and show you all. The imaginary axis for lone pair of electrons, right? S. Okay, you can draw like this also, the imaginary axis for the lone. So this is what we are telling as a imaginary axis. All right. So two axial bonds are in one lone pair, while two axial are placed in the perpendicular to this. So this is what I will. So this is what, along with that, and this is perpendicular. So here it's like a man, right? Fine. So this is what we are telling is the C. So sorry, C. So shape. So you're able to understand what they are telling here is, right? So when you want to draw along with the whisper unit, I will show that one. So definitely you will able to draw the structure with all possible lone pair, right? Okay, this should be like this. Fine. Yes. So therefore, the repassion of the lone pair on axial bonding slightly distorted. There is no the regular seesaw shape. Hence, the shape of the axial V of axial 4 is we are called as distorted tetrahedral or distorted seesaw or irregular seesaw because of this alignment. So this is how it's aligned, right? So there is no, it's a regularly, theoretically, the repassion is slightly distorts in the regular seesaw shape. That's why we are giving the different name for this seesaw shape. Let's see the notes. Okay, this is what I just draw you and I showed you, right? So this is what the electron pair geometry of the SCl4. So finally, however, the repassion of the lone pair on SCl bonding electron slightly distorts the irregular seesaw shape. Hence, the shape of the SCl4 is called distorted tetrahedral or distorted seesaw or irregular seesaw. Right. Next, we are going to speak about what the T-shape. If you understand what I'm just doing here, so this is just more clarification there we are doing. But the summary, what is this? I have done in the first slide with my explanation. That is what you definitely need. When you take the electron bipyramidal pair geometry, there are 4 possibilities. How these 4 possibilities are shaped? This is what I'm talking here. Yes, when you speak about the T-shape, yes, there should be 3 repulsive units bonding, while the other 2 repulsive units are lone pair of electrons. So simply, for your understand, you can write this is as what? Here, you are having 3 bonding electron pair plus 2 lone pair. So altogether, 5 s per unit, that's all. The concept is same. You should understand what they are telling here is. So the best example is, okay, so the T shape. Without speaking about the example, I will say like that. So 3 bonding pair, just imagine what is the shape of the trigonal bipyramid electron pair geometry. So this is your M. Okay, this is what definitely it's arranged. Here we are talking what, okay, we'll say this is as a L as a ligand. Okay, just for the explanation, don't be confused, M and L, right? So here they are telling 3 bonding pair and you need T shape, right? So what you have done in a seesaw, yes, seesaw, For the distorted one, to get it as a regular from this, what you all have done is we have rotated because it's a planar. You can rotate whenever. So we have done the axis like this. N, right? This is for distorted seesaw. Now think, what is for T? You need T shape. Should be very careful about that. You need T shape. So again, you can rotate this axis. So I need T shape. Make it as a T shape. Sorry. L and two lone pair like this. So can you see the shape is there? Your trigonal planar and axis. Can you see the shape is here? Your trigonal planar and the perpendicular axis. Yes, this is how the T shape arrived. Three bonding electron pairs along with two lone pairs. So this is what the example for the T shape, that is the ICL3. In the case of the ICL3, the most stable shape with the minimum repulsive force between the Vesper units is given below. The sketch of ICL3 results in the T shape. Here also, it's somewhat is not in order, so that's why you can say the distorted T shape or irregular C shape when the surrounding CL atoms are considered. Therefore, it is called as T-shaped molecule. So guys, so even though we have given the different names, so you can, for the examination, just giving the T shape also will be enough. So this is what here, what we are telling is two lone pairs and one ICL bonds are in one plane, while the remaining two ICL bonds are like perpendicular to this plane. I said, okay, so when you speaks about the, right, when you speaks about the shape, right, okay, sorry. Here two lone pairs and one ICL bonds are in one plane. So again and again, I said, when you speak about the trigonal bipyramidal, this is what actual thing is. Okay, your central atom, trigonal planar, and one axis perpendicular for that plane. This is what the shape of this. So according to that, what they are telling is you are speaking about the ICL3. I is a central atom, right? So two are, okay, guys. So what is happening here is, so they are telling is the ICL bond are in one plane, while the remaining two ICL bonds lie perpendicular to that. So this is what happening here. Okay, along with your two lone pair, one ICL bond in the plane, right? And other two are perpendicular to your plane. This is what the shape of the ICL3. The word is clearly mentioned. One ICL bond are in one plane the two along with your two lone pair and one ICL bond in the one plane, that is the trigonal planar. Another two ICL bonds are perpendicular for this plane. So they are telling, what we are telling is this is ICL tree. So simply it's given the electron pair geometry of ICL tree. So the final one, we are going to speak about the linear shape. If you understand up to now how we have derived the different shapes from the electron pair geometry of the trigonal bipyramidal. So here, this is also seems to be similar. Here, this is the concept is you will have two repulsive units, two bonding pair, bonding electron pair, repulsive units, while other three lone pair. So altogether, it will give 5 West per unit. Right? Okay. So from this, you can definitely see what should be the possible one. So I will explain you. The two bonding electron pair and three lone pairs. Okay. So again, the one plane is, you can draw, one is as what? The same plan, and the three lone pair, the two bonding pair will be to the perpendicular for this axis. So you can draw this is as, we'll say metal atom, right? You need, so one, all three, right? All three lone pair in one plane, and bonding pair is perpendicular to this. You can draw like this, M, or you can draw like this also, doesn't matter. So the concept is you have to know what is that your three lone pair in one plane and the bonding pair perpendicular to that plane. That is the concept, right? And let's we check the example now. So you can see the lone pair, and this is the shape, the linear. What is the angle, right? So let's we move on. Xenon F2. So all these types, all atoms are in line. Thus, the molecule has the linear shape. The following Lewis structure illustrates the linear shape of the xenon F2. So I will draw and show you how the xenon F2 is arranged is. Right? The xenon is here, okay? That is your central atom. The three lone pair in one plane. This is what they are telling is. So 1, 2, 2, 3. One plane, and other two bonding pair perpendicular to this axis. So xenon F2. So again, I said you all, you can draw like this also, it doesn't matter. The concept is needed, but this is what your imaginary is, trigonal planar. The lone pair at the trigonal axis and other xenon F2, F xenon fluorine, that axis is perpendicular to your trigonal planar axis, right? Sorry. Note that all three lone pair in one plane, which is a perpendicular to the xenon fluorine fluorine axis. So this is what they are telling is the electron pair geometry of xenon fluorine. So this is what, guys, the summary. I'll just go through the summary again, right? When you speak about the the bipyramidal, trigonal bipyramidal geometry. So you should able to understand. So this is one axis and your other axis perpendicular to this. You have four possibility, right? If you have all five base per unit is bonding electron pairs. So you will have the shape is there is no change of the shape. Axis perpendicular. Then if four electron bonding pair plus one lone pair. So what is the possibility I say? Yes, you can draw this is like, okay, any shape, any type, or like this. Any shape doesn't matter. If three bonding pair plus two lone pair, so the shape is T shape. You can draw this is as T shape. Okay, think like that. Okay, so two lone pair and one bonding pair in one plane, another two bonding pair perpendicular to that axis. Finally, if you have two bonding pair plus three lone pair, your shape is, you can draw this is as like this. Think like your all three lone pair in one axis, other two bonding pair is perpendicular to that axis. This is the concept. And what are the shape? Let's rewrite the shape now. What is this shape? Trigonal bipyramidal shape. What is the shape of this? Yes, seesaw shape. That's enough. No need to say distorted or whatever. What is the shape of this? T shape. And finally, what is the shape of this? Linear shape. And what is this geometry? Trigonal bipyramidal electron pair geometry. That's all, guys. This is what I expecting from you. Okay. So please go through this. It's really easy if you understand this one by one. We already spoke about all possibilities of each and every geometry. Next, we will study about the octahedral geometry. Until that, see you. Bye-bye. Assalamu alaikum wa rahmatullahi wa barakatuh. Take care, guys. Be safe.